Okay, so here's another problem, for example, for class 10 in dynamics. So this is out of beer Johnston, and this is sample problem 1311. So we have this 4-ounce baseball is pitched with a velocity of 80 feet per second towards the batter. After the ball is hit by the bat B, it has a velocity of 120 feet per second in the direction shown. If the bat and ball are in contact for 0.015 seconds, determine the average impulsive force exerted on the ball during the impact. So that's like a typical kind of impulse that you'd see when you have like this impact, right? That you're going to have a large force for a small duration. So working the thing out right here. I'm going to write out what the mass of the baseball is first, so we can see it's an itty-bitty number, right? So we have, it's 4 ounces, and we know that there are 16 ounces per pound, and 32 feet per 32.2. Why did I leave 32? Why did I leave the 0.2 off? I don't know. 32.2 feet per second squared. 7.764 E minus 3 slugs. Right. So let's draw the impulse momentum diagrams for here. So we have the initial, we have the impulse, and we have the final. So initially, the baseball is traveling in that direction right there. So there's mass times velocity 1, right? And that's in the x direction, right? So 1. And we'll say that this is x and this is y. Now we're going to hit it, right? So there's going to be some type of force, and maybe I should make it a force on the outside. It's still a particle, right? So we're still dealing with particles right here. So the physical size doesn't matter. So we could say that you know, it's really kind of getting hit like right there. But we'll say we have the Fx dt, delta t, and then the Fy delta t is happening during this. And then it's going to be equal here. Well, we're going to get a mass times velocity 2 right here, right? So there's B in this direction and in that direction. And so we know that that's a 40 degrees, and we know that, and we know this. Okay, so we're golden. So we write out in the x direction, we say that we have, it's negative right here, so we have negative mass, or 7.764 E minus 3, times the velocity, which we know is 80, right? And then it's going to, this is positive, so it's plus Fx 0.015 seconds. And so it's going to be equal to, right here, it's going to be that positive right here, 7.764 E minus 3. I didn't leave enough room for myself. It's going to be 120 feet per second, but it's going to be the cosine of 40. Did I do everything right? Yeah, I think so. And I get an Fx equal to 88.99 pounds. And it's positive. Now I want to do the y direction. And maybe we want to do it with and without the weight, because we didn't put the weight on there. Right? So that's going to be 4 ounces divided by 16. So it's 0.25 pounds. So you could do the math yourself and figure out how little that's going to be in there. And I'll do it for you. 0.25 times 0.015. Right? So we're going to have 3, I can't see it, 3.75 e to minus 3, right? So 3.75 thousandths of a pound. So let's see, in the y direction, we're going to have 0. Here, we're going to have Fy times 0.015. And if we wanted to, we could also say 0.25. That's the weight of the thing, 4 ounces. 0.015. And it's going to be equal to that slugs right here. So it's going to be the vertical portion of this right here, 7.764 e minus 3, 120 sine of 40, right? And so my initial numbers right here say 39.92 if I neglect this right here, but let me go ahead and put those in there, right? So 120 times 40 sine times, okay, but let me subtract out the 0.25 and the 0.015. So that actually adds over to here, right? It actually adds to the thing. And then 0.015 we divide. So I end up getting 40.17 pounds upwards. So we compare, though, to 39.92 pounds if you neglect the weight. And so if we go ahead and we take what the force is going to be, and I get my 88.99 squared and my 39, not 39, I'm going to use this guy's right here, 40.17 squared right here. So we get the 88.99 in our we get 97.64 pounds. And what's going to be interesting is the direction of our hit for the thing, right? So let's take the inverse tangent, and we're going to see with our 40.17 and our 88.99 right here, 40.17 and our 88.99, and take the inverse tangent, and we get 24.29 degrees. So in order to make the ball go at 40 degrees, we have to hit it at an angle of 24.29. That's not intuitive, right? You would probably, if you were an amateur, a novice hitter, you're going to be trying to hit the ball in the direction you think you want it to go. But you need to hit it at like a steeper angle right in there, not a steeper angle, but a less shallow angle to go the direction that you want. So that's the answer to this problem. Let's check and see what they did in the book, right? So this is supposed to be in example problem 1311. Let's check it out. I'll pause it and then pull up a copy of the book right here. So, okay, so it appears that in this edition, this is example problem 1316, right? And here's your little three diagram thingy, and you can see that the values are a little bit different because they neglected weight, right? So I said 97.64, they have 97.5. No, not surprising. But anyway, here you go. It says, in this problem, we neglected the impulse due to the weight. This would have had a magnitude of this right here added to it, 4/16. I'm going to buy mine's a little different from theirs. I thought I just did the numbers right there, right? Why is this my 0.25 times 0.015? Yeah. How come those aren't the right numbers? Isn't that weird? 4/16 times 0.015. And they didn't get the right number. 4/16 0.015. Yeah. It should be 0.00375. And they got the thing wrong. How is that possible? Is my brain not working? Or is that's just crazy how that would possibly be true right here. So anyway, the end. That's weird. Am I losing it?